In number 71, a conservative force acts on a 2 kilogram particle that moves along the x-axis. The potential energy associated with the force is graphed over the side. When the particle is at 2 meters, which would be right here, at this point right here, they tell us the velocity is negative 1.5 meters per second. What are the magnitude and direction of force at this position? All right. So first of all, just before we get started on this one, remember that the total energy is the sum of kinetic and potential energy. In this case, you can tell that the potential energy is going to be negative 7 at this point. And we know the kinetic energy, 1/2 m times v squared. They give us the velocity is negative 1.5 meters per second. We can figure out the total energy of the particle at any given point is this. And because we're dealing with conservative forces, the total energy's got to stay the same. So how do you answer A? Pretty simple. We just need to find the slope of the graph at that point. Well, the slope of that graph, if you work it out, let's see, we're looking for it at this point right here. If you look at the slope, we go from there to there. You can estimate it's about negative 5. And that would be joules per meter. And remember that the negative slope, or the negative derivative of this, gives us the force. So if the slope is negative 5, the force therefore has to be positive 5. So what's the direction? It would be indicated, the force would be actually towards the right, or in the positive direction. Yeah. Oh, there we go. C. What positions on the left and the right can the particle move? You're like, what? What limits that? Well, in this case, we know that the total energy is negative 4.75 joules. It can never go above that. And so if we look at this, the answer on this side is approximately negative, or x equals about 1.5, right about here. At that point right there, my potential energy is going to be negative 4.75. The kinetic energy at that point has to drop to 0, and that's as far as we can go over in this direction. What about the other side? Well, if we look at it somewhere right around here-ish, the potential energy is again going to be negative 4.75. So right around here, around 14 meters, is the limit where its kinetic energy goes beyond, or goes back to 0. Why can we not go beyond that? Well, at this point, the kinetic energy would have to be negative, and kinetic energy can never be negative because we always square the velocities. And finally, what's the particle's speed at 7 meters? Well, at 7 meters, we're right down here. And at that point, we know the potential energy is about negative 17, just based on this. And we can figure out the kinetic energy 1/2 mass times velocity squared. We just have to solve for the velocity, and if you do that, you'll discover it's moving about 3.5 meters per second. Hopefully that makes sense. It's a good way of reading a potential versus position graph.